No niin, kello on 9.00 Suomen aikaa tässä ja aika aloitella pikkuhiljaa Nohan ja HMS:n tällainen yhteistyöseminaari. Ja huomenta vaan kaikille, tässä on Marko Repo, Nohan vetäjä Suomen osastolta ja olette liittymässä tällaiseen meidän väylätekniikan seminaarisarjaan. Tänään on aiheena tällainen CAN-teknologia ja sen ajankohtaiset teemat teollisuudessa. Ja tämähän tehdään yhteistyössä ruotsalaisen HMS:n kanssa ja meillä on asiantuntijana tuolla taustalla Freddy Dahlberg ja Saksan maalta sitten Ixatilta Norbert Binder tämmöisenä asiantuntijana. Ja tarkoitus olisi, että Norbert vastailee tämmöisiin teknisiin kysymyksiin, eli teillä on siellä tällainen chattiruutu, chatti-ikkuna, mihin voitte kirjoitella tällaisia kysymyksiä ja kerrottikin englanniksi. Ja tässä sitten webinaarin aikana niin Norbert vastailee näihin teknisiin kysymyksiin ajan puitteissa ja toinen mahdollisuus on sitten, että näitä käydään yhdessä lävitse sitten tämän varsinaisen webinaariosuuden jälkeen. Ja oletusarvoisesti nyt voidaan sanoa, että noin tunti saadaan menemään varsinaiseen osuuteen tässä ja sen jälkeen tulee nämä yleisökysymyksiin vastaukset. Ottakaa kaikki irti tästä meidän yhteistyövebinaarista ja mukavaa aamua kaikille. Freddy, the floor is yours.
Okay. My Finnish is not that good, but thank you for the introduction and welcome everyone to this webinar. Today we will talk about reliable and future-proof communication with CAN. My name is Freddy Dahlberg and I'm the Business Development Manager for our Ixat brand. And as you heard before, Norbert Binder is also on the line, our Technical Services Manager.
Hello and thank you for joining.
Thank you. Okay, so if you have any questions during the presentations, we're happy to answer them, but please try to write in the chat and we will get back with answers during the presentation. So if you don't know where the chat is, there's this button it will show up on the screen where you see the presentation. Okay. So this is the agenda for today. I think that we will go through it quite quickly so that it doesn't get too boring for you. And we will also allow for a lot of questions at the end if there's something you want to ask about. So first, just some information about why we think you should choose HMS and our Ixat brand. Then some points as to why CAN are a good choice for your communication. Then we will go through the exciting stuff about how you can build and optimize your CAN networks. And lastly, how to make your system future-proof. Okay, so this is where I am at, our head office in Halmstad. And in a world where all devices are intelligent and networked, HMS is the leader in making industrial devices and systems communicate for a more productive and sustainable world. We have over 8 million HMS components in use worldwide. HMS has been a trusted partner since 1988. We are over 600 employees with 20 offices around the world. 2019, we had a turnover of 1,519 million Swedish kronor, or around 150 million euro. Okay, so that's about us. Now, why CAN? So the easy answer is it's field proven. Released in 1986 and CAN in automation was established in 1992, many years ago, which means it has really been tested. CAN is integrated in most industrial and automotive microcontrollers, and many devices and controllers are available on the market. With established service providers for development and troubleshooting, and that CAN is used in many machine control and special machine application, makes CAN a good choice. It is also robust. It works reliably in harsh environments thanks to its differential signal being robust against EMI influences. And I will talk a little bit more on that later. Also, the way the communication works provides collision-free communication. CAN is easy to implement and install. With many devices available off the shelf, this reduces the development effort. The 3-wire setup makes assembly of cables easy and inexpensive. It is also quite easy to analyze the network. You can just connect at any point and you can see all the traffic. It is even possible to do it without cutting cables. So 8 bytes of data does not seem to be much, but CAN is sufficient for many applications with just 8 bytes of data and transmission rates between 10 kilobit and 1 megabit. Of course, CAN-FD also offers up to 64 bytes and up to 15 megabits, but that's a different story. This is why it is used in so many different applications. Okay, so where is it used? Typically inside machines, not so much factory floors, but even there it happens. So some examples: coffee machines, fire trucks, vending machines, computer tomographs, construction machinery, batteries, wind turbines, safety cameras, elevators, sport vehicles, and ships. Okay, now let's talk about some challenges and how to build and optimize to get over them. So, some everyday challenges might be network related. So, like overall cable length, number of devices, if you have bad cables and connectors, aging of components, settings in devices that cannot be changed, or simply difficult cabling. It might also be usage-based, so changing the network, adding further devices, connecting network to Ethernet-based protocols, or retrofitting existing machines. So let's first talk a little bit more on cable length and maximum distance between devices. Basically, you can say that the longer distance you need, the lower speed you can use. So you see here the speed and the length of the cable, and you have to be inside this area. And here's some examples of the maximum cable length and which bit rate you can use. So let's look at line topology in this example. Maximum bitrate on CAN is defined by the distance in meters between the most distant nodes. So in this case, node 1 and node 15 are the furthest away from each other. And this creates a critical path of 440 meters. And the maximum bitrate you can use is 150 for the length of cable. So what about if you need more speed? If you then add repeaters and change the topology a little bit, you put the repeaters here, the blue ones. The critical path is instead between node B and D. And this gives a logical value of 200 meters, and you can easily use 250 kilobits instead of 150. And in this case, you also save about 150 meters of cable, which actually might end up paying for the repeaters. So now you might ask yourself, why does it say 40 meters here next to the repeater? And that's because of the delay inside of the repeater, which corresponds to the same amount of time it would take for the signal to travel in 40 meters of cable. So when you calculate it and are using a repeater, you need to add this. But as you can see, it saves you a lot anyway. So another example, what about if the topology looks like this? Then I will give you two different solutions depending on your situation. So first again, use repeaters, but this time change to a star topology. In this case, all messages are forwarded to every segment, and also the segments will be galvanically isolated from each other. The second option is to split the logical layer with a CAN bridge. This enables usage of different bit rates on the different segments, and also message filtering that can be used to save bandwidth. So only the messages you want are forwarded to the other segment. So as cable length limits the bitrate, you might want to segment your network even if it's not possible to change the topology. Again, use a CAN bridge, and in the logical segments, messages can be filtered and even different bitrates can be used. So what about if things are very far away, like in a large building or a large ship? Then what to do? In this case, we also offer the capability to forward CAN over existing or dedicated Ethernet networks using our CANetNet. And then everything can be sent from this segment to this segment to that segment and so on, using the Ethernet cables in this case. So another challenge is the number of devices. What about if you have more than 80 devices? Then you might run into problems with the signals becoming too weak. This is because CAN transceivers do not have enough power to drive the voltage levels of so many devices. Again, a CAN repeater can be used, which then amplifies the signal. Now I'll show an example of a weak transceiver, bad cables, connectors, or just aging of components. So this is a measurement of the signal quality. As you can see here, the quality is not so good from this node. And then again, if you look at the actual signal, you can really see that this is beginning to become an issue. This is then easily solved using a CAN repeater that amplifies the signal. Okay, so what about if configuration of devices cannot be changed and you need several of the same device in the same network? So examples, ECU test stand in production, or maybe you have 4 boat engines that all needs to get the communication, and they have the same identifier in the network. Or a train that have several cars. With the CAN bridge, the identifier can be changed to be able to connect several of the same device. Also, you can filter messages so that, for example, in the train, only what is needed in the next car is forwarded. So this saves you bandwidth. So what about EMI? Yes, I know we talked about how robust CAN is, but sometimes there's just too much. So that signal doesn't look too good. So what happens if we add a CAN repeater? The EMI and we isolate up to 4 kilovolts. Now look at the signal. Looks perfect. So we offer galvanic isolation up to 4 kilovolts, but also with fiber optic solutions, you can get virtually unlimited galvanic isolation. So you cut the copper cable and you put the repeater on each side, and you have fiber optics in between. Then it's completely isolated. And also the fiber optic cables are not affected by EMI. So for really hard cases, an option could be to build the entire network with fiber cables and just connect each node to the repeater. Mechanical stress can also be an issue after some time, cables wearing out or even breaking in heavy-duty machines. Something might get stuck during the work and break. Another thing is difficult cabling. That can be a challenge where you cannot run cables or you don't want to plug in. Like a racing car, you don't want to plug it in. Our solution to these challenges are go wireless. With CAN Blue, we offer cable replacement, and you will also get similar benefits as with the CAN bridge. As also here, we can use different bitrate, change identifiers, and filter messages. With the industrial Bluetooth connection, we can achieve up to 200 meters distance. Also, it's worth mentioning that Bluetooth technology is a bit different from Wi-Fi, as it supports something called frequency or channel hopping and adapts to the conditions to find available frequency automatically. This makes it a lot more robust than Wi-Fi. Another use case where you should consider going wireless is when only dangerous access is available for the machine, or if you simply want to be able to work on the network without having to connect cables. Okay, so to summarize optimizing your CAN bus network, the CAN repeater will split the physical layer to get rid of EMI or to optimize topology, like creating a star topology. The CAN bridge will in addition also split the logical layer and allow you to change identifiers, bit rates, and also filter messages. A CAN gateway like the CAN@net will in addition also combine with other kind of networks. All of these products are available from our partner Know-How, so get in touch with them today. Okay, that was it on build and optimize CAN networks. Samuel, did we get any questions?
No, not really. People having problems with sound and the picture, but we are recording it.
Yeah.
So.
Okay. Okay, moving on. So how to make your system future-proof? So first, let's look at something old. This steam machine as an example. Here you have some analog measurements of RPM, temperature, pressure, and so on. A change to CAN-based sensors can then be connected then you can connect it to the cloud. Even our CANet can act as a master and start up the network, so you won't need a PLC. You can just connect these sensors to the CANet and then connect it to the cloud. So, send status and alarms. Again, with the CANet, we can send CAN data to an MQTT broker. This can then be sent as alarms to an operator or to a SCADA system, or even some cloud solutions to analyze the data. So with our solutions, you can keep existing machines and get them connected with new ones. So different technologies, CANopen, Profinet, EtherCAT. Keep existing machines, connect to other parts of the factory, interconnect various technologies. We have the solution for your communication needs, and our partner Know-How will help you in finding the solution for you. So get in touch with them to discuss your next project. Thank you. Do we have any questions? Feel free to unmute yourself if you want to ask a question. Marco, do you want to say something?
Not at this stage, but if you have any questions, you can also use the chat box to feed any questions, and we can also discuss them afterwards. It seems we have one question coming here.
So I think we have a question here. So I heard that there is no internal security in CAN, given that it will most likely connect with networked components. How to make sure of safety? So Norbert, maybe you want to answer that?
Yeah, I can take over here. So usually, as it was introduced at the very beginning, CAN is usually used inside a machine, and connecting the sensors and all the components within a machine or a system, and therefore the security is more or less given by that people from outside usually cannot go into the machine and directly connect there. So you're absolutely right. There is no direct security in CAN. But nevertheless, some of the protocols have a mechanism in there that will filter out messages which are not valid, and so that's a possibility to check and confirm what's going on. And also, you can always add on application layer mechanisms to filter out commands which are not suitable or make sense at this certain state of a machine. So that's something you need to solve an application there. But usually up to now, the machines are on the factory floor, it's closed systems. So the main protection for CAN networks is that they are not accessible from the outside. And usually, as I said, it's closed system, so there are not many possibilities to connect from the outside. Did that answer the question, or is that?
Yeah, so I think what we are saying that that the security of the network can then be in the other protocol. So if you if you transfer CAN data to a different protocol, then the security can be there and the CAN is only used inside the machine.
That's exactly it. Also with the CAN.NET, there was the example, some slides before with MQTT and transmitting data into the cloud. The main target application for the CAN.NET is to have the data or to keep the data within the factory, so within the own network. Of course, you can always connect to an MQTT broker which is outside, but then you have to include some firewall and other protection, so nobody from the outside can access the communication to that MQTT or traffic and control the machine. So CAN.NET in our case has one main path for communication with MQTT or towards the cloud, and that's really from the device to the cloud, so it can show data or bring data from the machine, from the system up into the broker and to a cloud, so customers can use signals and production data and so on on the dashboards in the monitoring system and control system. But for the standard mechanism, we don't have a way back, so nobody can from external control the machine. There's an option now on the way for also bridging data in both directions, but there you need to define exact commands and in an exact order, and you don't have to use that. So you can simply disable that and have production or have a security on that mechanism as well. So you have also your own way on control to keep the security of the system. So if you have a CAN network on premise and your own control stand and so on premise where you want to move data to, then it's okay to go both directions. If you go outside your own factory floor and really in a public cloud, then it's recommended to use the one-way communication just from machine to the cloud, so nobody can interfere with your machine.
Okay, thank you. We also got a question about the input voltage for the CAN Blue, and Frank, thank you for the answering. And Norbert, one more question here. Do you see some Ethernet standard eventually replacing CAN buses?
It's hard to say. So if you look at a CAN, it's basically only the physical layer. There are several, several higher layer protocols like CAN Open, which introduced device and application profiles. And those are copied by several industrial Ethernet protocols. So, for example, EtherCAT or Ethernet PowerLink. And another proof that CAN Open and CAN is field proven. But nevertheless, it always depends a lot on the application what you have. So, for example, if you look at EtherCAT, it's very strong in controlling drives, machines, moving parts where you have a lot of access. But if you have bigger data packages, if you want to transmit image data or other big amounts of data or big packages of data, not big amounts, but big packages of data in one go, then EtherCAT is not the best one. If you look at Ethernet PowerLink, it's more like you have a big truck where you can put a lot of stuff in, but it's not moving so fast. But you can transport a lot of big packages. So it always depends on the application, which is best. But if you have a dedicated use case here, we can always take a look at it and give you a recommendation and tell you what we think could be suitable there. But there's no defined, standard or protocol on Ethernet which is directly following the CAN and CAN Open.
Okay, so we have another question about the Bluetooth security in CAN Blue. So, like for protecting against man-in-the-middle attacks.
Frank, can you take over here, or is that? Should I do that?
Yes, if you have a fast answer, then please I think there's some,
There are some mechanisms to hide the visibility of the devices, so you can only connect to dedicated MAC addresses, and only if you know that this device is there. So basically, there's already two mechanisms. One is to hide the devices, so you can only connect to a device where you know it's there. The second one is you can define dedicated MAC addresses for pairing. So you cannot connect to any device, but you have to, before or when you install it, you have to define what is the other device, which MAC address does it have. And so that's already two big ways of protecting the communication. So nobody from driving by can basically access that. So that was also one of the big requests we had from the company producing the safety cameras for the red lights. So they wanted, of course, to make sure that nobody in the car driving by can switch off the camera, or someone standing at the crossroad with a mobile phone can switch it off or trigger a picture. So it's basically, we use all the possibilities which are defined in Bluetooth to protect the communication there. But we're following the standard.
Super. Okay.
And also the distance, as Cam Blue was mentioned before. So the 200 meters we're mentioning there, that's what we can make or can ensure that it works. We had tested the same modules here, and we stopped, I think, after 500 meters or so, because the road where we were testing was not long enough. So if you have good weather conditions and good, not too much steel in there, you can reach much further distances. But only, of course, if you have a pair of the Cam Blue. If you have a mobile phone or a PC, then the Bluetooth module of your PC or mobile phone is limiting the maximum distance. So because usually you can reach maybe up to 5 meters with a mobile phone in Bluetooth connection.
Yeah.
But for most applications, that's also sufficient. Just if you want to go by for service and configuration or monitor checking the status of a device. That's all fine.
I guess that's also a valid point from a security perspective, that it's a bit different if you're bridging and using it as a cable replacement. I guess that's the highest type of security. If you're using it to connect wirelessly from your mobile phone or laptop to the network, then the Cam Blue is visible, and the security is more like password protection, like in a Wi-Fi system or similar.
So you also have the PIN code to, as you have it when you pair your mobile phone with your car. You have to enter the PIN code, and you have to know that, and that's also something you have to change. We don't have only the standard or default PIN code, as is often given in cars, but you can also change that and have your own PIN code. So you really have to know that to establish the pairing.
Yeah. Okay. I guess that's about it. We thank you, Freddie, and thank you, Norbert, and everyone at ICSAT for this presentation. And if you have any more questions, please contact Know-How and Marco, and they will help you and guide you. And thank you for all your questions and for participating in this webinar. And wish you a good day.
Okay, thanks for joining. And if you have questions, just don't hesitate to ask them.
Great, thanks.
Thank you.